All right. Hi, everybody. I'm Jacob. I'm here with Jason, who's our head of product. He keeps a really close eye on IP and regulatory developments. And there's been some pretty big developments happening, especially out of the EU. So, Jason, talk to me about the EU's Ecosystem Design Rulebook and what that means for OEMs of electronics products.
So the Eco-Design Rulebook is really looking at trying to make devices more green and setting a set of rules around how you design them, certify, and test them to make sure that products are meeting sustainability goals.
What kind of rules? Like, what do they have in mind?
So one of the big things is a common use case of why these tests are coming up is someone leaves their phone on overnight, right? And it's fully charged, or their smart glasses or earbuds on a charger, and they don't pick them up, right? There are rules around how much energy that device can use when it's actually not really going to charge the battery.
Right. Is this what we call vampire power sometimes?
Vampire power is one thing. It's light load charging. It's basically majority of the energy is being dissipated not to do something. It's just kind of
It's just being wasted. And the EU wants to cut down on waste when, it's one thing to charge a battery that has utility. It's another thing for your smart glasses to be sitting on your nightstand full and continuing to consume power.
Correct.
That's what they're kind of trying to cut down on.
And it's important because there's two use cases: a fast charging use case or something where it is going to sit on your nightstand overnight.
Yeah. Cool. So, all right. So that what you just described is not really taking into account whether it's wire or wireless charging. That's just for all chargers, right? So how does this impact wireless charging, what we specialize in?
So from a wireless charging perspective, inherently, people assume that we are more inefficient. And at higher powers, yes, that may be the case. When we start looking at very small form factor devices where we have lots of little wires connecting to pogo pins, other types of interconnects for glasses or earbuds, wireless charging and wired charging are actually relatively similar in terms of performance.
Okay.
So when we start looking at that specifically, and we start looking at these light load situations for wireless charging, we're really trying to figure out ways to make sure that we meet the standards of Eco-Design Playbook, which we think wireless charging is also going to bring you into this space.
Okay. Interesting. So this is on the heels of the Common Charger Initiative, which mandated that all radio devices use a USB-C connector. This was really, people thought it was about going after Apple because they had their proprietary Lightning connectors, and the EU wanted to eliminate that waste and create a common charger. Now, where do the Common Charger Initiative kind of left open a loophole around wireless charging, so you could kind of do any wireless charging. You had to use USB-C wired charging if you were going to use a wired charger, but it didn't really talk about wireless charging. So that's been interpreted to mean you can use any wireless charging. Do you think the EU is going to keep that loophole open, or do you see things developing on the landscape?
I think it needs to develop. I mean, fundamentally, compared to USB-C, which is very mechanically rigid and you know exactly what you're going to plug into, wireless charging is so much more inherently tied to the industrial design and use case of the product. But something that works in a cell phone is probably not going to work inside glasses or earbuds.
Mm-hmm.
So when we start looking at what the EU is doing, and with an ultimate goal of enabling an ecosystem so people can buy a case from one company and be able to charge a product, and making things much more standard and unified
and reusable, because they don't want people to be generating e-waste by throwing a charger out with every product. If you can use the same charger over 5 generations, that really substantially has a major environmental benefit.
Correct. And I 100% agree with that. You need to define the interfaces appropriately for those products to make sure it works. And with wireless charging, the form factor really defines how the interface is going to look.
Okay, now for the Common Charger Initiative, talk to me a little bit about how you see, if you were a regulator in the EU, how would you define the type of technologies that would be the common interface?
The way I would define the technology that would be the common interface would be, first and foremost, looking at the mechanical design and use case of the product, looking at sizes, form factors, designs, variations, and then looking at the available standards in the market to make sure that they align with the performance and use case characteristics of each one of those products, right? So
talk to me a little bit about the standards. So right now in the world, there's 2 predominant wireless charging standards. We have Qi and we have NFC. There's a third one coming with Key for kitchen products. How do you look at, should it just be one? Is that what's going on? Is this like one should do everything? Or are you looking at dividing up the types of devices in some way? How do you think about standards?
I think it needs to be divide it for the best use case. If we look at Wi-Fi, Bluetooth, Zigbee, the wireless communication specs, they all have a specific use case and they're all really widely adopted, right? So we start looking at wireless charging. You have WPC and Qi that is really good for cell phones or things that are very flat. We start looking at things sub 5 watts that the WPC from a technology perspective doesn't inherently really meet.
Yep.
You look at things like NFC that gives you that flexibility from a design perspective. It just makes more sense from an integration and end user that the NFC will attack those smaller products. When we talk about Qi, that's even higher power, right? It's actually a combination of both NFC and Qi to make a use case for charging happen. So
Over a kilowatt.
over a kilowatt.
Yep.
So it really depends on the use case. And I think that there are right technologies that are adopted by tons of people that are based on standards that just need to be appropriately applied.
So in summary, you think that the way that standards will go is less akin to wired charging, where you just said USB-C, that's it, that's your only choice. You think it's more like wireless communication, where there's Wi-Fi, there's BLE, there's Zigbee, there's LoRa, there's all these other standards. That makes more sense for wireless power too, because power level, device sizes, use cases, those all drive what's the efficient and optimal type of technology for that application.
That is correct.
Cool. Well, thank you.
Of course.